Good evening, ladies and gentlemen. Good morning to the friends who has joined from our East Coast and West Coast. Thanks for your time to joining today's session on how automation of big data testing can help avoid pitfalls of bad data. So my name is Abhilash Giridharan, who's working as a test architect with UST Global. I'll be your host for the day. Before we begin, few housekeeping things. This platform does not allow you to talk to us. So, but if you have any questions, you can click on the question mark on the top and you can put in your question. And I will ensure that we'll walk them through during our Q&A session. And as we all know that automation of big data is most disruptive technology changing its dominion completely. The power of big data lies in finding the patterns having some predictive values. It's further enhanced by automated process that help in identifying some specific data features. So while we speak about this testing of big data, I can remember a few testing challenges which came into my mind, like huge volume, heterogeneity, and testing huge volume of data is the biggest challenge in itself. Understanding the data, dealing with the sentiments and emotions, lack of technical expertise and coordinations, and few things like stretched deadlines and the cost. So now let us hear from our panelists, and we start with our guest speaker, Eric Smith, who is our Director of Partner Services from RTTS and a decade and a half of expertise in automation and testing of data. And we also have Joseph, test architect from UST Global, who have 14 years experience in technical consulting, services, and test data and big data testing. Without taking much of the spotlight, I'm handing it over to Eric to start with the webinar. Eric, all over to you.
Thank you. Thank you, everyone, for joining. What we're going to do today is go through a few slides as an overview. Joseph John, test architect at UST Global, is going to kind of give a high-level presentation on the challenges and the UST Global approach to overcome these challenges. And then I'm going to follow up with a few slides on an automated solution to address those, and then a short demonstration. So with that, Joseph, if you want to go ahead and start the presentation.
Yeah, thanks, Eric. Hi, all. Hope everyone is safe and sound. So we'll start with our discussion today. So basically, as Eric said, I'll be starting with the different architecture pillars of a big data landscape and how we are testing and what are the approaches and methods we employ to test that. Then Eric will follow up that with the automation aspect using QuerySurge. So that is our agenda. Hope we'll be starting it now. So let me start with discussing about Hadoop big data landscape. So when we look into a big data landscape, basically the decision to employ a big data will come from a business decision. Like they want to look into the analytical aspects of data in their disposal. So and when we start, most of the data will be outside of the Hadoop system, and we need to ingest the data into the Hadoop layer. So that is happening in the data ingestion layer. So there are different technologies we use to ingest the data. So the major ones are Scoop is there, then for relational data, the data from relational database to move into a Hadoop file system. Then you have streaming data, which will be handled to Kafka or IIDR. So basically, that is the data ingestion aspect of it. So once the data is ingestion methodologies are involved, the data will be moved to the row zone, which will be the HDFS zone where the data will be moved as it is. So there won't be any change in the data. The data will be residing in the Hadoop file system. So the basic aspects we look there is like the data quality or whether there are some bad data over there. So the next aspect is we are moving from raw zone to staging zone. The staging zone is the place where we actually do cleansing on top of the data, or we will do some data sanitization. If I take an example, so like we will look into data from a particular time period. All these things comes in the staging zone, and the data will be stored in Hive, which is the data warehouse within HDFS. So now we have the data at our disposal within HDFS. Then we will move to the confirm zone where we will do the analytical process. So there are different technologies used for that. The major one is Spark. Then you have Storm. Storm is also there, Apache Storm. Then Thais, as well as Apache, Kafka Stream is also there. So these technologies will be used to do operational processing or an analytical processing on top of data according to the business requirement. So now we have the data available with all the transactional business or analytical operation done on the data. And then we move it to physical zone, where the application will use it for their requirement, where the data will be stored within Teradata or NoSQL database, so that the application can use that. So this is about a high-level picture of Hadoop big data landscape or Hadoop ecosystem we normally see. There are multiple technologies involved, but we are dealing today with the major one we face encounter. So now we look into the big data testing types. What are the in a much more detailed way? Like as we said, right, there are ingestion layer, then there are different HDFS layers, and then we will use it for the OLTP or any other processing aspects. So basically, the testing will evolve around the data validation. Like once we ingested the data, after post ingestion, we will look into the schema validation, whether the data is correct, or the data what we are looking is having that correct data quality, the data integrity is correct or not. That will be done in post ingestion. Basically, that happened within the data ingestion layer to the HDFS layer. Again, another aspect is like post transformation, as we said, right, in that confirm zone, we will use Spark or Storm to do transformation. We again use the duplicate, whether check whether the data duplication happened, or whether the data quality aspects are matched or not. Again, when we look into the data, there are two types of data we basically handle within big data landscape. One is like a batch data, like so for in an organization, there will be data which is already residing, maybe in an RDMS, that we do move it to HDFS in a batch way. Then there are certain streaming data which will be utilized using Kafka to have to take a decision from certain streams. So these are the different big data testing aspects we look into. And testing big data landscape means testing the architecture landscape. When we when we say architecture landscape, we are not looking into how a yarn or a job scheduler will schedule your job, that is to the HDFS layer. We are looking in a business ontological way, like what are the areas we are employing what are the components we are employing for our particular architecture, and we are discussing about that. So moving on to that, so the first architecture pillar is like the data ingestion stage, right? So as we discussed, there are different ways in which data gets, so that is one aspect of the data, the variety of data. So it can be an RDMS, then it can be a log, it can be any other OLTP or any other stream data. So basically, the validation we do here is like the equivalence checks, like whether the data moved from the operational data system or from any source is correctly moved to that HDFS, so that we are not adding any bad data within the pipeline. So that is the testing normally we do. And again, cell difference, whether we miss some data, so that the analytic is dependent on all these fields, whether we are missing some data or we adding some bad data or junk data there. All these tests will be carried out here. So let us discuss about two major aspects. One is like Scoop. Scoop is a popular technology used to import data to HDFS. The Scoop, as you know, it stands for SQL for Hadoop. So basically, it connects to a database, then import the data to a Hadoop file system. In the background, Scoop is using MapReduce, and basically map jobs will be used to move the data to a Scoop file system. So there will be Scoop jobs running. So the basic testing will involve like we will test whether the structure of the file, the Scoop files is matching with that the databases. If you look into the scoop file, we can see it's a column separated row format. So will run test on top of both the table as well as the row structure and see whether the data is matching or not, whether any bad data has creeped in or not. So that is we are doing there. So we do test on top of that and making sure no bad data is there. Another aspect, as we said, is the real-time data. So here we are looking into Kafka. So Kafka it's a stream processing technology. So basically the concept in Kafka is you have a producer, then you have a Kafka topic, and as well as a consumer. So the idea of testing that is we will create our consumers and write test on top of consumer and see whether we are getting the correct value or not. So in order to test Kafka, we use a feature of Kafka called Kafka Connect. So basically, Kafka Connect is the common connectors created by the community. So basically, for our testing, we use one of the connector given by Confluence. We use KSQL, and so the connector will actually look into a particular KSQL connector will look into a particular topic and will create a KSQL DB. Once we have the KSQL DB, we can use KSQL queries to actually query that DB and see whether the data is correct according to the format or not. So we can look into the data, the current data, or the first data. So many options we can do there. Whether you look into a particular time period data, all these things we will query and see whether the data is correct or not. So this is about the data ingestion aspect. So at this point, we are ingesting the data from the outside, and then we are moving the data into the HDFS. So now we move to the next stage of Hadoop landscape, which is into that Hadoop infrastructure. Right now, our data will be in the Hadoop file system, and here we are dealing with the canonical data. What do you mean by canonical data? Is for every business, they have certain aspects on what are the business value we need to look into. So we define that in the canonical model, and the data will be moved into that canonical format, and the data will be stored within Hive. Hive will be the the data warehouse used within HDFS. So basically, again, so this is as we discussed, this is the place where we do cleanse the data according to our canonical model, whether any bad data is there or any other data desanitization is required. So normally how it does is people will write either a Pig Latin job or a Spark jobs to cleanse the data. Suppose, as we discussed, the time period or some data need to be modified accordingly. So that will be run using Pig Latin or Spark. So how we actually test is basically we use a serialize, deserialize method or library of Hive to create internal table of Hive. So what it does is the ser deserialize option of Hive help you to create data with the schema of your liking. Suppose you are getting data in a semi-structured way, like JSON. What we can do is we can create in a Hive table using the deserialize method, and then we can define the schema according to the canonical model and see whether the data is correct or not. And again, once we have the table structure, we will do SQL HQL queries, basically, which is similar to the SQL queries. Hive provides SQL queries such as to count or average. So many things, so many query constructs are given by Hive itself. So we will make use of that. So that is how we test the data cleansing aspect of it. So once the data is cleansed, again, as a developer, as a big data and architect, what developer will be doing, they will be creating external tables as a data warehouse, right? So So that is a place where we move the data to the data warehouse, and there actually we again you make use of the Hive SQL queries and user-defined functions. So there is a capability within Hive where we can define user-defined function according to the business requirement or the message transformation requirement. We will write the Hive user-defined functions, and we will normally that we will write that in a Java file or a Java program, and we'll get that data and we will validate that. So that is how we test that the data architecture or the data warehouse aspect. So again, once we have the data in Hive, we can combine that with HBase, which is a NoSQL data for further use. How it works is like HBase can be queried using shell script. Maybe it can use a get or a scan method to look for a particular value and see whether a particular value, the value we are looking for, the analytical aspect is within the tables. We can check that. So now the data has been moved to HDFS, and we have our data available in Hive as well as HBase database. The next thing what we do is like in the confirms on, we will do the analytical. So analytics. So basically, we will have the business transformation rules for, according to our requirement, analytical requirement. So as we know, there are different technologies we can use here. The major one is Spark. So we are discussing Spark on that. There are other things as we discussed, like there is you can say Storm is there. Then you have Kafka Stream is also there. So we are using Spark context Spark here because Spark help you to work both in historical data as well as streaming data. So testing of Spark again has two aspects. So basically, first is to have to create data for that the particular transformation. So how we generate data is like we'll use Java APIs to access to that HDFS file systems, and we can either create data dynamically from the different data constructs, such as a tuple data or a data model. Then again, we can import the data either from a CSV or a Parquet file, and we can make use of it. And the another aspect, once we have the data, the second aspect is like we need to do the transformation. So basically what we do is like we first load the Spark context in our test. Then we will do the data set comparison or data frame comparison. Then we will compare whether data frame is giving you the correct data sets or not. Again, that RDD construct such as filter or map again is used to assert certain values. So the same within the Java code itself, we are using it to assert and find out the value. So again, till now we talked about the historical data. Again, here also we can use Spark streaming to do the streaming aspect. So basically the methodology is same. Only thing is like instead of Spark context, we are loading the Spark stream context, and we are using D streams. So D streams for getting the data, dynamic data, and again we are using filter and map to do assert on based on the business transformation values. So this is how we basically do validation on the different architecture pillars. And so this is normally how we do it in a manual way. So the tools such as QuerySurge can help you in automating these aspects, and that is what Eric will be covering, and I'm handing it over to Eric now. Eric, yeah.
Thank you, Joseph. So what I'd like to talk about now is a little bit about QuerySurge. As Joseph mentioned, testing big data architecture is difficult. There are a lot of different layers, a lot of different components. There's a large volume of data that can be tested. So coming up with the proper strategy and the proper solution to test that big data is going to be critical to any project success. So I'm going to be talking about QuerySurge, which is an application that our organization created, which is the smart testing solution for automated validation and testing of data. It is a product designed specifically to test data on a large scale and large volume. I've worked with Joseph on several different projects, doing proof of concepts, illustrating QuerySurge as a solution that can automate those tasks in this big data architecture. So whether you're dealing with data warehouses and ETL processes, whether you're dealing with big data systems like Hadoop and MongoDB, whether you're doing data migration projects, BI report testing, enterprise ERP systems that have multiple data feeds, anytime you need to test a large amount of data between different systems, QuerySurge can be used to assist in that process and automate that process, allow you to test in an efficient way. So essentially, the way QuerySurge works is we have a concept of a test, which is called a query pair. And what a query pair does is connects to any two data points at one time during execution. In the query pair, you'll define a source system. That source system could be a traditional database. It could be a mainframe. It could be a flat file or some type of service. And you'll also specify a target system. And the target might be a data lake, a data warehouse, a BI report, big data system. And essentially at the time of execution, what QuerySurge will do is it will make a query to the source system, a query to the target system. It will retrieve analysis result sets, and it will do a comparison of every single cell of every single record that's retrieved. And it will look for any type of data anomalies, such as maybe records from the source system that didn't make it into the target system correctly. Or maybe there was duplicate records that made it into the target system that didn't match up with your original data set. Or maybe there was something that got truncated improperly due to improper transformation logic. All these types of bad data issues will be captured and we'll be able to provide metrics and analysis on that data, as well as automatic email triggers to send notifications to team members anytime there is an issue encountered. As you saw from Joseph's presentation, there's lots of different technologies that we're dealing with, whether it's streaming systems, whether it's big data lakes, or whether it's Hive tables. You need to have an automated solution that is able to connect to all the different types of applications, platforms that are part of your data architecture, and be able to work with them seamlessly and be able to get the data out of them in order to conduct your automated testing. QuerySurge supports over 200 different data stores. Just a sample list is what's listed here, which you can illustrate on the slide, which are some of the more common ones that you may encounter on your typical projects. The way QuerySurge accesses the data, it uses JDBC drivers. So essentially, as long as there's a JDBC driver available for the system that you're working with, that driver can be loaded onto a QuerySurge agent and then can be used to request data and integrate it as part of your testing solution. So what we're going to do today to show you how this can be done is try to provide a small use case and try to simplify it as much as possible so you could see the different components and how you could go about automating this process. So we're going to start with a streaming Kafka system. So Kafka has a messaging service. That messaging service can constantly be sending messages. And we want to be able to validate that these messages are going to make it into our big data system. So in order to do that, we are going to take that data and have it processed into a file. Joseph mentioned some of the different ways that can be done and some of the different technologies that are used to kind of take that streaming data and get it into a structure that we can work with. That file is then going to be loaded into our HDFS file system. And then we're going to put a layer on top of that by taking that data and loading it into a Hive table. So as you can see, we have a couple different data points here. So of course, the challenge is how do we go about testing this to make sure that the streaming information eventually makes it into that Hive table? Well, we're going to devise a set of tests that are going to be used to automate the testing of this process. So first, requesting the data from the stream using KSQL. We're going to use a KSQL JDBC driver. We're going to create a QuerySurge test that is going to compare the information coming directly from the stream to the information in the file. We're going to create a separate test, which is going to compare the information in the file and see how that is going to make it into the eventual Hive table. And lastly, we're going to have a third test, which is going to compare the data from the initial stream all the way to the Hive table. Now, again, these tests, you can choose one or multiple sets. If you choose validation point 3, you'll know if there's an issue, but you might not know exactly where the issue occurred within the architecture. by running the group of tests, not only will you be able to know right away that there's a problem, you should be able to locate exactly where the bad data or the defect was introduced. So again, just to kind of further illustrate this point, we're looking to capture and test data from the various sources. We have our Kafka stream. We have that Kafka stream data that's eventually making it into a file. And then the information that from that file is eventually making it into a Hive table. So we need a way to automate and test the data through these different systems. So the way this is done in QuerySurge is the following. We will design our tests or query pairs where we will specify the source system, the target system, and the data that we're requesting from both. We will take a bunch of these query pairs for the various different endpoints that we're looking to test, and we're going to load this into what we call a test suite, which is simply a collection of query pairs that are going to be executed together. And lastly, we're going to set up a scenario which is going to execute that suite, run the tests, and then provide us results, whether those tests were successful or whether we ran into any type of data anomalies that need to be addressed. Now, one of the key factors here is not only do we want to be able to just run the automation of the validation process, but we want that validation process to be able to fit into whatever type of automated DataOps pipeline that you may have set up. So what we're going to do is this is the process that we're going to demonstrate for you in a few moments. We're going to take that process of moving the data from the stream into the Hive tables and automate the testing and tie that all into a DataOps pipeline. We're going to do that using Jenkins, and the Jenkins job is going to provide a couple different tasks. The first is to capture the data from the file stream. So it's going to go ahead, get that data from the stream, and load that into a file. Once that data is loaded into the file, the next step is to load the file into our HDFS system. And we're going to take that information and load it in. Once the file has been loaded into HDFS, next is to update the Hive table with the most recent information. So Jenkins will go ahead and have the Hive table refresh and pull the data. And lastly, we want to be able to now run the QuerySurge validation tests to automate the testing of that process. So through the QuerySurge execution API, it's going to query the various different systems that need to be tested, and then determine if there are any type of defects. And if everything is successful, then obviously you could go ahead and continue with your pipeline. But if you do encounter some type of issues, you may want to trigger an automatic email notification indicating that there is some type of problem, maybe do a rollback procedure if necessary. So those are the tasks that we're going to look to demonstrate. So what I'm going to do now is I'm going to share my screen. So just give me one moment while we turn the screen sharing on. And what we're going to do is, before I log into QuerySurge, I'm going to show you the different components again, just in their raw form. So as I mentioned, we have our Kafka data stream, and you can see the streaming data listed in this command window. We're taking that data and we're going to be using KSQL to be able to retrieve that information out. So just to kind of illustrate that point, I'm bringing up a standard database querying tool. And you'll see that I have set up a Kafka connection, which is using KSQL to access that stream. So I'm just going to run a couple queries here just to illustrate that. You'll see I'm showing the different topics that are listed in my Kafka instance. I'm now going to run a quick query just to show you the streams that we're going to be working with. So I'm dealing with this orders raw stream. That's part of the orders topic, which is in JSON format. And then lastly, I have my KSQL query. So this is the query, which is going to retrieve me some data from that stream. Now, whenever you're dealing with streaming systems, you do have to put some type of limit or filter to specify specifically the data sets that you're looking for, because otherwise it'll just keep requesting data. So we just put a basic limit on this to retrieve us the first 20 records that are coming from that stream. So once we have that data from the stream, again, that data is being moved into a flat file. So you can see right here, I have this Kafka output file, which is taking the data from the stream and is loading it here. That file is going to be loaded into our HDFS system. So I'm using the Hue application to kind of illustrate or get a peek into what's going on in my big data environment. So you'll see here I have this Kafka output file that's been loaded into my HDFS system, and we have the data that's here. And then lastly, that data is going to be loaded into a Hive table. So if we take a look, you'll see I have this table called Kafka data. And you'll see a basic query here, just giving me, again, the first 20 records, and then bringing that data back. So you can see the different data components. You can see the data within the different environments. So now we're going to go into QuerySurge and show you how to design tests specifically designed to verify the data is correct in all the different systems that we just touched on. So I'm going to toggle into QuerySurge. QuerySurge is a web application. You access it through your browser. When you first log in, you will see an user dashboard, which is going to provide information that's relevant to that user so they can track the metrics that are of interest to them. But what I'm going to do is draw your attention specifically to the design library, which is on our left-hand side. You can see we have a folder structure that enables us to store all the tests that we're creating. I have a specific folder set up for this big data webinar that we're taking part in. And if I drill into that folder, you'll see I have a couple different query pairs. I'm going to draw your attention to the first three at the moment, which are testing those various segments of that business use case that we walked through. So validation point 1 is testing the information from the Kafka stream going to the file. Validation point 2 is taking the information from the file and putting that into the Hive table. And then validation point 3 is going from the first point, which is the Kafka stream, all the way to the end point, which is the Hive table. Now I'm going to open up one of these query pairs just so you can see what it's comprised of. So you'll see we have a source side on the left and a target side on the right. For both the source and target, we have a connection dropdown. And the connection dropdown is whatever technology you're looking for this particular test to access. So you can see from this dropdown, I have many different technologies set up in this particular environment, as this is a demo environment, so it's able to showcase different technologies that we can test. But you can see in this particular test, I've set up something to connect to the Kafka stream. And again, that is to get that streaming data out of that orders raw stream that we looked at earlier. And on the target side, I'm just going to be connecting to a file. So we have JDBC drivers that allow us to access information in files the same way as if it was in a database table. You can run queries against the file and retrieve that data. So at the time of execution, what QuerySurge will do is it will execute the source query, execute the target query, return all the data, and do an analysis to see if there's any type of data problems. So I just want to drill into the results of this past execution. So you can see in this particular query pair, we did have a failure. We had 20 records that were returned from our source system. We had 20 records that were returned from our target system. So those numbers matched. So that's a good thing. We have a 0 row count difference. However, we did have 2 records that had some type of data mismatch. So out of the 20 records that were tested, 2 of them have erroneous values where the source data doesn't match the target data. So in order to determine what that is, we're going to have to dive a little deeper and view the query results. So as I drill in, what you'll see is QuerySurge is able to display the source data. So this is the data that was captured from the Kafka stream using KSQL. Second, we have the target data. This is the data from the file that was going to be loaded into our HDFS system. And then the third tab, which is really what we're interested in here, is the failures. So what was the reason that these particular records failed? So if you remember from the previous screen, out of the 20 records tested, only 2 of them had data failures. So these are the 2 records, and from the 2 records from the source, and then the 2 records from the target. And if I scroll over, what you'll see is QuerySurge will highlight any data mismatches that it encountered between source and target system. Now, what you can see here, if you look at the order date on the source side and the order date on the target side, it looks like the date's the same, except that the first digit is incorrect. So it looks like however the data is being processed into our file, it's not able to account for double-digit dates. So anything with any date through October through December is not going to come into the system correctly. So QuerySurge was able to do this analysis and do the comparison and tell you where there are issues. Now, because this is a big data topic, obviously 20 records is pretty small, but just to kind of show you that QuerySurge can do larger data sets, I do have another run where QuerySurge was testing 10 million records of the same data size. And what you could see is QuerySurge is able to do those large data sets. In this particular case, we didn't run into any issues. The data matched between source and target, so we had it pass. Now, to do these 10 million records, it took a little over 14 minutes to complete. And this is on a very underpowered system. If you look at my demo environment here, I only have 4 gigs of RAM. I only have a couple processors that I'm using. And the HDFS system that I'm connecting to is also just a single node. So obviously, you could drastically reduce the amount of time for testing really large data sets. But even with my minimum specs, I was able to test 10 million records. It was, I think, about a half a gig of data on the source side and half a gig of data on the target side in the time frame specified. So you can use QuerySurge to do this same process that we're doing with a small data set with really large data sets. So the next thing I want to show is once you've created the individual tests that you want to run, the next thing you can do is you can group them together into a suite. So in the QuerySurge scheduling section, what you'll see is I have a suite called Webinar Big Data Kafka Use Case, and I have the 3 validation tests that we've put in here that we want to execute. So anytime this suite is executed, it's going to run these query pairs. Now, I only have 3, but if I needed to add additional query pairs, you can see my design folder on the right-hand side. I have the ability to drill into these folders, either add individual query pairs, or I can even add an entire folder if I want, and it will add all the individual query pairs from that folder in manually. And then, of course, I can save those changes if I need to make any modifications. So now that you've grouped your query pairs into a package that you want to execute at a particular point, we can run these in a couple different ways. We can run them on demand, where I can just hit Run Now. We could schedule a scenario where I can specify a specific date and time and add the suites that I want to execute. But what we see a lot of customers really interested in is to do event-based driven testing, where after a particular job is finished, to fire off the validation test designed specifically to test if that job is successful, and then to report back quickly on the overall status of those tests. So what I'd like to do then is to toggle over to Jenkins. Jenkins is an open source build solution. And what I have here is a build setup to do this exact task. What this build is going to do is query the data from the stream, dump it into the file, load the file into HDFS, load that file into the Hive table, and then automatically run the QuerySurge test to do the analysis of that execution to verify whether those jobs were done successfully. So let's go ahead and kick this off. I'm going to go into that project. I'm going to kick off my build. I'm going to then take a look at the output of the Jenkins build. So you see the first step is to load the Kafka data into a file. So pull the data from the stream, load it into the file. You'll see the captured data here. That's being dumped into the file. Step 2 is to take the streaming data and load it into the file system. And you'll see that step has been completed as well. Then we refresh the Hive table to make sure that it has the latest data. And then step 4 is to run the QuerySurge validation tests. Now I'm going to toggle back into QuerySurge and go to our run dashboard. You'll see on the left-hand side, this blue icon indicated that this particular use case, or I should say suite, is queued up. And now it's running. So we're running those 3 query pairs that we talked about. you'll see the graphs on the bottom to indicate the current status of what's going on as those tests are running. We also have a line chart to kind of give you the status over time. And over on the right, you'll see the summary metrics, where it will tell you how many tests passed and how many tests failed. And just as we would expect, if we drill in, we're getting the same results. So you can see the 3 validation points we tested. The Kafka stream going to the file is where we have our error. Going from the file to the Hive table seems to be working flawlessly. But of course, if we have an error in any step of the process, validation point 3, which is testing the overall process, going from the stream to the Hive table, is going to have an issue. And if you look again, we have our source data, our target data, as well as our failed results, that when we do the comparison, we can specify specifically what records had the issue. Now, if I go back to Jenkins, it's important that the status gets reported back to the pipeline. So what you'll see here is that when we ran into the failure, we failed the Jenkins build. So we could put in any type of conditional logic that is needed to say, well, if everything was successful, then go to the next phase of the pipeline. However, if we do encounter errors, maybe kick off some type of rollback procedure and notify the team. One of the ways we can notify the team is with automatic email triggers. So if I refresh my inbox, you'll see we just had a new email that came in that said we ran a scenario that didn't pass. It was the webinar Big Data Kafka use case. If we open this up, we'll get details on what was executed, what passed, and what failed. So what you'll see is we only had 1 test pass out of 3, which is why we have a 33% pass rate for the query pairs that were executed. However, we did 240 verifications, and we only had 4 data failures, which is a data reliability score of 98.33%. So both of those numbers are important. Not only do you want to know, well, how many of your tests were successful, you also want to know how accurate your overall data is. And you can see here we had 98% data accuracy. Below that, you'll get more details as far as which suites were executed, as well as the individual query pairs. And I'm not going to do it here, but if you clicked on any one of these links, it would open up a new tab, ask you to log into QuerySurge, and be able to see the raw results like we were looking at before. Now, assuming that you were able to take this data, and I should showcase this, QuerySurge gives you the ability to export this data out into either an Excel, CSV, or XML file. You can also hit export all, and it'll take all these different tabs and export them into an Excel sheet. But if you're able to provide this information and pass it along to the development team, then they can put in the fixes, and then you're able to run that automation process again, and hopefully this time it will pass. And we'll do just that. So I have another build set up in our project where we believe we have the issue resolved. We're going to build it again. And in this case, it should be set up where the issue that was encountered, which was pulling the data from the streaming service and loading it into the file, should have fixed the issue with the I should say the dates from October to December. And after this process, again, is complete of loading the file and accessing the Hive tables, the last step is to rerun those QuerySurge tests and make sure that indeed it has fixed. So if we go in there, I'm going to go back to our run dashboard. You'll see we queued up our next run. And it's going to go run those same 3 validation points that we ran before. And in this particular scenario, you'll see all 3 of them have passed, which means the defect has been resolved. And we can go back into Jenkins, and you'll see that we had no errors this time after our QuerySurge execution was completed. So again, this was a simplified use case, just trying to break down a couple segments of big data and showcase how the process flow would work, how QuerySurge can be used to automate these tasks, and how easily you can take that information and add it to your DataOps pipeline. And of course, taking these same principles and building upon them is how you come up with a robust solution for automating big data architecture and coming up with a way to root out that bad data that can sneak in to your system. So that concludes the demonstration portion of the webinar. So I'm going to stop my screen sharing, and I think we're going to open it up to deal with some questions that may have popped up.
Hello, Abhilash. It seems your audio is not working. Can you hear us? Still, we are not able to hear you.
No?
Yeah, I think that problem with Abhilash audio. So let me take the questions, Eric, while Abhilash fixes the audio. Right, so I think the first question is more towards you, Eric. So is it correct that in the real world, Jenkins would be run by the DevOps team, QuerySurge test would be created by testers, and data movement or transformations would be run by the ETL developers?
Yeah, that's correct. So the DataOps team will kind of drive the DataOps pipeline.
Can't hear you, Eric.
Can you hear me now?
Yeah, I can hear you.
Okay, so
Yes, we can.
the answer to the question is yes, that's correct. The DataOps pipeline will be typically done by the architecture group. The ETL process is going to be done by the development team, and the data testers are the people who are going to use QuerySurge, design the tests, and then those tests get loaded up into the pipeline as illustrated. So yes, that is exactly how that flow would work.
Perfect. Thank you, Eric. Abhilash, do you want to take your audio now?
Yes, can you hear me now?
Loud and clear. Go for it, man.
Thank you. So I think the next question is for Joseph. This question is, since the processing is all direct moves and there is no business logic or transformation, where would you expect an anomaly here?
Yeah, so basically the example shown by Eric is for data ingestion. So as we see, the data is going from the Kafka to Hive table. So that is the data ingestion part. So the anomaly basically comes within the processing layer, which is in the Spark layer. That is what we earlier discussed about the Spark jobs being tested using a Java framework. So we use that filter and map constructs there to do the assertions on top of that, and that is the place we see business value.
Looking back, I think, Eric, there is another question for you. It's around the results of mismatch. Do we get the results of mismatch between source and target?
But when you open up a query pair execution, you'll see the source data, you'll see this target data, and then you'll also see the failures, where it will do it will give you the details of exactly what failed within that particular execution. That data can be exported out of QuerySurge, either through into an Excel or CSV format. Can be done manually. We also have the ability through our API, if you want to set up automated processes to pull the failed data out and maybe load it into another platform or another framework. QuerySurge has the capability of doing that. So all of the failures are visible, are stored, and can be accessed if needed.
Thanks, fantastic. So the next one is it correct that in the real world, Jenkins would be run by the DevOps team and QuerySurge test would be created by the tester, and the data movement or transformation would be run by an ETL developer?
I think we did have that question earlier, and we addressed it, and the answer was yes. That is essentially how that process would work.
Thanks, Eric. Since that, Joseph, you have joined back and you want to continue with the previous question?
Yeah, so as I was explaining, the business transformation will be handled using Spark level testing, so which was not shown because right now we were discussing on the demo about the data ingestion aspect, while business transformation will be handled separately using the framework which is written over Java, which there we will find the anomalies from transformations.
Okay, thank you, Joseph. And the next question is for you verifying the data between file and the table. Was the file placed on the QuerySurge server and accessed that way? Or was the file stored in another location like cloud environment and accessed from there?
Yep. So to answer the question, the data does not have to be put on the QuerySurge server in order for QuerySurge to access it and use it as part of the testing. What has to happen is wherever the QuerySurge server is installed, the QuerySurge server gets connected to agents. The agents are not part of the technologies that you're testing. They're specifically agents for QuerySurge. And as long as those agents have connectivity to where the data resides, then QuerySurge is able to pull that data in and do the comparisons. So, for example, if you have flat files that are saved somewhere on a shared drive, as long as the QuerySurge agent has access to that shared drive, it can go to that file, pull the data out it's needed in order to do the analysis. So you do not need to pull the data onto the QuerySurge server in order for QuerySurge to work. The only requirement is QuerySurge have connectivity to wherever the data resides.
Thank you. Then the next question is around the QuerySurge enabling BI reports testing as of now.
So QuerySurge does have the capability to test BI reports. We support several different vendors. And essentially the way QuerySurge works is we have specific drivers that are utilized to be able to pull the data out of visualizations of these vendors. So for instance, if you're using if you have a Tableau BI report and you have a bar graph, what QuerySurge will do is we're not going to test the visualization of what's displayed in the bar graph as far as how high or how low the bars are. But what we are going to do is pull the data behind those graphs, pull it out, and then we can use that as either a source or target. So we can take that data and maybe compare it against the data mart that's feeding into the report. Or maybe we take that data and compare it against another report, or maybe against the original source data, wherever it came from. So for any of the supported BI vendors that we currently work with, you can use QuerySurge to access that information.
Thank you, Eric. I think with that, we have done with the questions which we have got. And within interest of time, if anyone has having any last questions which we need to get it clarified with Eric and Joseph, you can go ahead with that. And if it not, then we can wind up the session. Okay. So I think that's it. That's for the day. If you have any questions, please feel free to email to assurance@ustglobal.com. And I'll ensure that we will be we will be sending the reply and answer for that questions to you. Once again, thank you very much for the guest speaker, Eric, and for accepting our invite for present the POV today. And many thanks to our Joseph on excellent session. Thank you very much for your time, and bye for now. Thank you all.
Thank you. Bye-bye.
Thank you, everyone. Take care.